What's going on, guys? My name is Hussein, and in today's video we're gonna explain what's the difference between an index scan and an index only scan. How about we jump into it? So I have here a Postgres database and I have pSQL, and I have a beautiful table here with no indexing or anything like that, right? So I have an ID, a grade, and a name of the students. Look at a bunch of students table. Very simple table, right? So what I want to select here, for example, if I select the name where from grades where ID equals 7, you can see that this particular person's ID 7 is named Hussein. And if I do like select star from grades where ID equals 7, you can see that the grade is 81. It's all boring stuff. So what we're going to look at as database engineer, we're interested in the what the database did to fetch this row. So we do explain, analyze, and we do the same query again. Select name from grades where ID is equal 7. And since there are no indexing on the predicate on ID equals 7, the database decided to do the only thing it knows, which were parallel sequence scan, which is the table scan, which goes to the table itself and just literally one by one search every single row, pulls it, and then look, is it ID 7? Nope. Let's look at the second one. Is it ID 7? Nope. Until it finds the ID 7, right? And it took 400 milliseconds to do that. And it returns one row, essentially. That's how we should look here, right? So that's what it did. So now we know how to create an index on this ID because it's powerful stuff. So if I do create index ID index on grades, and let's say on the ID field, right? So this way we're going to create a B-tree index so that searching is a little bit faster. And that's a completely different structure from the table we talked about. This table that has, I think, 10 million students, right? So now we just created another table, given that ID, that beautiful tree, so that is way better in searching. We can search that in that index in a very different way than we're searching a huge table. So let's do the same exact thing on this table. And just like that, we went from 300 for 400 millisecond to 1 millisecond in the index. And we look at this. It says index scan. I want to differentiate between index scan and index only scan. We're going to come to that next. It is an index scan because, yeah, we use the index, which is called ID index, to search for ID 7, and we quickly found out that. However, what's not mentioned here is we had to go back to the table to actually fetch the value name, because that's what we're asking for. We're asking for the name of the student, right? And the name of the student is not in the index. The only value in the index are the IDs. And we found the ID, but we had to go back to the table. So that table structure we talked about, the one we scanned earlier, it's there. And we had to go back using the reference, the row reference of the table, to jump back to that table, fetch that ID number 7, and fetch that whole row. That includes the name, the grade, and pretty much any other columns as well in the table itself. Beautiful stuff. So if I change this query a little bit, guys, and I asked only for the ID, does the database need to go to the table? The answer is no, because the ID is right there. Obviously, this is a silly query, right? Because the value is 7. But look at this. It says now index only scan. That is powerful. It says index only scan because it did not have to go to the table. And that, if you can execute queries in your application so that they are index only scan, you hit the jackpots. Index scan are great, are nice, but index only scans, ooh, they're the beautiful. However, this is a silly query. How do we make this a little bit more useful? Here's what I'm going to do, guys. There's something called non-key columns, where as we create indexes, and I created, and I actually made a video about this topic. Check out here. But we can drop our index. Let's go ahead and drop our index, and we're gonna recreate our index ID IDX on grades on the ID. However, while we're creating that, I know that most of my queries, when I query for the ID, are asking for example, the grade, or for the name. I barely ask for the grade. I only ask for the name, for example. So I'm gonna actually include the name field in this index. This is called a non-key column. This is called a key column. This is what we're gonna search against. This is what we're gonna fetch from the index, right? So it's not gonna be using this for optimization or searching. This is just what we're gonna store in the index so we can pull the information very efficiently. So now if I do this, I'm gonna create a brand new index, same exact index. What the difference is? We now pulled the values from the entire table, the name, into the index, just the name column. So now if I do the same exact query, and I'm not gonna ask for the ID, I'm gonna ask for the name. What do you think is gonna say? That the planner is gonna say index only scan. Beautiful. Why? Because we asked the database, hey, find me ID number 7, student with ID number 7, but go back and give me the name. The database is, oh, wait a second, I'm not gonna go back to the table, that huge 10 million scary table. I'm staying right there. The name is actually in me, in the index. So there you go. Just return it. So that's why it took much faster to execute. Beautiful, powerful stuff. So now if I change this from name to grade, that's no longer an index only scan. It's an index scan. Different. Why? The grade is not available in the index. So we had to go back to the table and fetch the row, and we took the hit in order to fetch the grade. So guys, this is what I wanted to explain in this video, guys. And pay attention to the cost of these things, guys, because as we work more with a large index, and including non-key columns in the index, can actually increase the size of the index. And if you increase the size of an index, that could be really bad, right? Because the more the size, the bigger the index, the slower it gets to query it, because you had to fetch more and more pages to get into the things that you're looking for. So just be careful with that. Just have an idea of what your query looks like, what your structure looks like. This is very useful thing, guys. That's it for me today. That was the sequential scan, index scan, and index only scan. Hope you like this video. Give it a like, subscribe for more backend engineering stuff. I'm gonna see you on the next one. You guys stay awesome. Goodbye.